welcome back. Our next presenter is from the foreign land of Ruby. He's a Ruby developer by trade. He's working at Source Labs as their Ruby evangelist. He gets to help other developers make things. He's going to talk to us about web testing for ninjas. Please join me in welcoming Dylan Lacey.
Thanks, everyone. So, I have a little disclaimer first up. This is a Python talk. Everything in it is Python, but I will be mentioning Ruby just a little bit. So I'm kind of going to flip-flop between some doco, some testing philosophy, and some general pro tips. So if you're looking for just one of those things, maybe you want to just come back and read the slides later. But so why am I here? Why is a Rubyist coming to talk to you about testing? I mean, that doesn't make so much sense, right? So I am the developer evangelist at Source Labs, which is kind of a role, it's a bit weird. We sell a developer product. So rather than having suits and marketing people, we have developers who help other developers use our stuff. And so I help people get going, I deal with our integration, I do our support, I do screencasts. And Source Labs ourselves are a cloud-based product similar to Heroku, but where Heroku does application platforms, we do testing platforms. So we have browser OS VM combinations. We have about 150 of them. And what we do with those is we give them to our users so they can test things. Astute people will have noticed that that's the same as the original number of Pokemon. So I talk to everybody at work. We're a Python shop, and I ask them about testing, because we do a lot of testing, surprisingly enough. We do all the browsers, we do all the operating systems, we all do all the versions and all the languages and all the tools and all the frameworks for sufficiently low values of all. And I am interested in developing, I love testing, and I talk to people at work about different tools. And so Ruby has a thing for testing. We may actually have a testing problem, but it's not a problem. We can stop anytime we want. We love it. And there's this tool in Ruby called Capybara. And so I talked to people at work and said, hey, there's this tool called Capybara. Here's what it does. Is there a similar tool for Python? And I got what seems to be a very Pythonic response, which is, oh, there's a whole lot of things that do that. Oh, okay. What are they all like? Oh, I don't know. I've never used them. So I investigated one, which is Splinter. Splinter is also a giant rat. A capybara is this huge kind of hamster thing. It's ridiculously big. And Splinter, of course, is the giant rat from Teenage Mutant Ninja Turtles. Now, Splinter is awesome. Splinter is a DSL for doing acceptance tests in browsers. So it can sit on top of a whole bunch of different browser automation tools and run through a browser in a language that reads better than most of the internal tools languages do. It's relatively tool agnostic. It doesn't have a huge number of things it supports, but it supports some integrations that are fundamentally different. So what you can do is you can switch platforms underneath Splinter without changing any of your tests. You change your config code, and that's all you need to do. It doesn't support everything, obviously, but you could probably write adapters for most of your favorite tools if they don't already exist. It currently works with Chrome, Firefox, Phantom.js, Zope Testdriver, and Selenium remote browsers. Selenium is a fairly common browser automation tool that supports most of the major browsers. Zope Test is Zope Test. Phantom.js is a headless WebKit JavaScript-based automation framework, so you can run your browser and get a DOM and a JavaScript engine without having to actually take up a monitor somewhere. So when I tell people about this, sometimes I get funny looks, because I said it's an abstraction, because it is. And people have problems with abstractions. People think abstractions are evil, because the concept of an abstraction comes paired with the concept of a leaky abstraction, which is an abstraction that has a bit that's missing that either causes you problems or doesn't work properly or gets bigger over time. And this is true. This is a very real problem with abstractions, but a lot of abstractions don't actually have this problem. If they're leaky and you know where the leaks are, it doesn't matter as long as you can avoid them. If they're not leaky, it doesn't matter at all. And the reason that abstractions shouldn't scare you whenever you encounter them is because all our programming languages are abstractions. Python is an abstraction of C, which is an abstraction of machine code, which is an abstraction of, an abstraction of assembler, which is an abstraction of machine code, which is an abstraction of bits. Everything we do is built on abstractions. Don't fear them. So acceptance testing is about running your test like a user does. Unit testing, you take a module or a method and you just make sure it works properly. Integration tests, you make sure the bits of your framework cram together and work properly. Acceptance tests should always run like a user does, because if they don't, you can't really guarantee that what you're doing is acceptable. They're the bit that takes what the user said to you they want and makes sure that that's what they're getting. Coding is fun. I love coding. I assume most of you do. If you don't, why are you here? But ultimately, it's a side effect. What you're doing when you're coding is you're trying to make sure your user is happy. If your user is happy, it's great that you managed to code, but you didn't give them what they wanted. You haven't achieved your goal. You've just had a bit of fun in your editor. So acceptance testing is really important. I said up there it's just as important. I don't think unit testing is anywhere near as important as acceptance testing. Acceptance testing is the most valuable thing you can do to make sure you deliver software that delights your users. And it's where we don't put our effort. We don't start at acceptance testing. It's usually what you add when you have a big team, or when you don't have any other tests to write, or when you're constantly breaking functionality over and over again. So that's what makes Splinter a great tool, because it sits on top of things like Selenium. This is one of the engineers that used to work at Source Labs. Selenium tests pages. It tests them by loading them and then doing stuff on them like it's a person. Isn't that cute? Selenium thinks it's people. People are your users. It doesn't matter if your PyUnit framework says all your unit tests pass. It's not going to use your software. It doesn't care if it can't log in. It doesn't care if it doesn't look pretty. Your users do. So that's my little rant on why you should acceptance test. If you want to come and tell me I'm wrong, I'm happy to argue with you during questions or afterwards. So let's get to the actual meat of the presentation, which is Splinter. Splinter only works with those versions of Python at the moment, but it's pretty easy to install. I didn't have to do anything except pip install Splinter. All of the docs talk about the development requirements and the installation requirements, and all of those are encapsulated by running pip install Splinter. I think they were just being a little bit thorough when they were writing things. And using Splinter is just as easy. Create a browser and tell it to do something. The great thing about Splinter, the reason I love it, is that all of the commands you give it read like you were telling somebody what to do. Visit that URL. In Selenium, you'd have to create a Selenium object and go selenium.navigate_to brackets, address, close brackets, wait, and then you would have to make sure it actually got there, because if it didn't, it might not throw an exception, it might just sort of give up. So, navigation. Navigation is a primary part of the things you're going to do when you're acceptance testing. It's really simple. Go forward, go back, reload. All of the demos are going to look like this because Splinter is really easy to use. Links is when it starts to get slightly more complex, because with links, you can do things that aren't completely specified, which I always recommend doing. Use the least specific version of a command you can possibly use, because that isolates your tests from breaking. Users will change the terms they use to refer to things all the time. They'll make them less specific, they'll make them longer, your marketing department will ask you to change them. If you can hook on a keyword that's important, like pizza, if you know whenever you click on a link it's going to be about pizza, and you just use that, your test will be more robust. It won't break quite as often. Visiting versus links is a paradigm that you get with acceptance testing. Visiting is telling the browser to go to a certain place, going to the URL bar, typing in URL, hitting enter. Linking is actually clicking on a link. So JavaScript events don't happen. JavaScript events that are link triggered don't happen by clicking on the links. Going directly to URLs, they only happen by clicking on the links. So once you've gotten somewhere, you can check its attributes, you can check the title, you can check the URL, you can make sure it was a success response, which means the response was 200, or that it just was a response at all rather than a server error, and you can get the code back. Most of those aren't that useful because Splinter will also throw exceptions if it can't do those things. But here's your first pro tip. Speaking of what you can check, don't check HTML ever. There is no point checking the HTML of a file in an acceptance test because it's irrelevant. What it looks like under the hood is not part of your acceptance test. What it looks like once it's rendered is the important part. The HTML is just the scaffolding. It's like looking at a building and asking, well, is the concrete using rebar? That's only relevant if you're worried about it falling down. What you really care about is the concrete going to fall down. So don't use HTML. You'll just get a bunch of stuff back. And even if you're checking for content inside of that HTML, it really isn't a very stable test. So my demo, the first demo, just proves that it works. It's not very interesting because, again, acceptance tests with Splinter aren't very interesting. They're really prosaic. That's what's great about them. They're easy to understand, they're easy to use, they're easy to play. So can everybody see that at the back? Cool. This is a basic Splinter test. I create a browser, I tell it to go to a page, I make sure it succeeds, and I check that the title is Ramen at Wikipedia, the free encyclopedia. I recorded all of my demos because I didn't want them to break with not having an internet connection. So I apologize if the video isn't any good. You can see in the corner there that Firefox is running using WebDriver. Firefox has built-in support for Selenium because Mozilla loves testing as well. That test is finished. It worked. Woo! Wikipedia has a title on each of its pages that mentions Wikipedia. Truly world-changing. So, being able to check the title isn't that useful. Being able to check the HTML is worthless, basically. But what you can do with Splinter is you can check that things are on the page. You can find them by basically every sort of structure that you can use to refer to them while doing JavaScript or parsing with a parse tool. They're not all necessarily that useful, though. So all of these finders return element lists with the exception of find by ID. Find by ID either succeeds or it doesn't because there's only ever meant to be one object with an ID on the page at any given time. If you look for something and it's not on the page, you'll still get an element list, but it'll be empty. So your second pro tip, don't ever find things by xpath. xpath is really, really brittle. xpath relies on searching through your page hierarchically. Even with relative paths, you have to be sure that you haven't inserted or removed an element somewhere relative to what you're looking for. The only case that xpath is really useful is when you're trying to look back up the page for something. If you know that you have a certain element that you can identify with a piece of xpath and something else you're looking for can only be found easily by relatively looking back up through the DOM, then maybe use xpath. But most of the time, it makes your tests brittle, it's slower than CSS, it's just generally a terrible idea. Also, don't use CSS. CSS is also hierarchical and kind of slow. Depending on your CSS, maybe you can make sure you're looking at one specific element or the element that you want, but maybe you can't. Maybe you add something else to the page. Maybe your designer alters your CSS behind your back and your tests all break. The point of testing is to make your tests succeed whenever the intent of the test is met. And if the name of the class that makes things blink changes, that shouldn't break your tests. So the most reliable one of those, the one that's used the most, is name and tag. But don't use tag either, because, again, it relies on there only being one instance of the thing you're looking for. Tags, by their nature, can mostly be repeated in HTML. It's all tags. You can't look for paragraphs, you can't look for headings unless you know you're only ever going to have one heading, which, again, you're projecting your design decisions onto your app tests. You don't want to do that. It couples your designs to your app tests. So really the most useful one there is name, ID, and value. Because Splinter interprets the web page holistically. It looks like a user does. It looks at the whole thing. Relative structure and assume uniqueness isn't holistic. It's, what's the word? It's specific. You're looking at the way you've implemented something. If your implementation changes, as long as you still meet your criteria for success, your test shouldn't break. So I said before, all of those return element lists. Element lists are lists. You can refer to the first, last element and index them by integer index. If you don't use a method on an element list, if you don't get a specific method, it proxies to the first element of that element list. So if you know you're only ever going to get one instance of something and you want to assert some content on it, you can just go blah.findbycss.whatever. Elements can have their class checked. You can check that they are visible. You can check their value. You can find them by class. Again, find by class, not so useful unless you know the class you've applied to something has been applied by you for a specific purpose. What you can do with them is assert against them. This is much more useful than checking the HTML and doing a regex or checking content. You ask if the text is present in the page or if the text is not present in the page. You can also make sure that elements just exist rather than looking them up and then checking that the list isn't empty. And all of the matches that are there are present as is element present or is element not present. We do a lot of clicking. You can do clicking. Find the element, call click on it. Clicking on a form button will submit the form, and clicking will also follow any redirects on links or forms. Cookies. Here's a bit more of the zen of testing. When you think about identifiers, think about what the user is seeing. So maybe you have a unique name for a link, but that name isn't seen by your users. The user sees the link text. Your acceptance tests are much more likely to say, when the user clicks on the link that says blah, than when the user clicks on the link identified by the name blah. Always think about the user when you're designing your tests. In anything, not just Splinter, but because Splinter is an acceptance test tool, it's much more useful. The really powerful thing about Splinter that I love is its form capabilities. Forms are the most annoying part of acceptance tests. You have to find the form, you have to find the elements, you have to set their values, and then you have to make actions occur on them. With Splinter, it's much faster and much easier. The top line there, fill, is for filling in a text field. You can choose options from radio buttons, you can uncheck options, you can check them, you can select from select boxes, and you can just find the form and submit it by calling click. There's a problem with Selenium, something that if you wanted to contribute to it, you could probably add to great acclaim. All of those are name only. You can't find elements by CSS or ID or xpath or any of the other forms on forms. You have to use the name. So up there, browser.fill, fill in the topping field with the value olives. I can't go, the CSS for that text field. I have to use the name. Forms can also take a dict to set them. So if you just want to marshal a whole bunch of form data up and give it to the form as a one-line statement, you can do that. It's the same sort of thing, name of the field and the value, and then you just pass it to browser.fill. You can also upload files with a caveat. If you are using Splinter remotely, file uploads don't work. The lower level browsers, all the Selenium browsers, allow remote file uploads, but Splinter hasn't had that change pushed upstream yet. So it only works if the tests you're running are running on the same machine. So if you're trying to run on your local instance against a staging server somewhere else on your network, that probably won't work. So my next demo, Splinter with forms. Again, it's a video. And I will just pause that video if I can figure out, no. I guess I can't pause that video when I'm presenting. That's terrible. I will be posting these slides online if you want to investigate them later. So Splinter executes the form. It opens Firefox. Firefox is the default browser, unless you specify something else. So it filled in the form, it fired the JavaScript validation, and then I deliberately stopped the test from stopping because otherwise it would have closed the browser. So that's the problem with Splinter demos. They're not interesting because it's really easy. One of the wrinkles about testing with Selenium is AJAX. AJAX requires your JavaScript time to execute. You need to give it time to do things because Selenium will go through all of the commands as fast as it possibly can. Splinter waits. So Splinter allows you to tell it to type into a field. So rather than setting the value of a field, actually act like a user and type. So it triggers key up, key down events, things like that. You can plus slowly equals true, and then you iterate through all of the text so that you can make sure that something happens. This is great for like auto-completion. So here I'm saying type into the color field the value purple, and each key it types, it will go to the block, to the iterator and iterate through, and you can do something like say, has the auto-completion field appeared? Does it contain values that don't contain the amount that we've typed so far? You can execute JavaScript with Splinter. This is both really powerful and really terrible. So you can execute any JavaScript that's valid, which means you can do all kinds of crazy things with jQuery and make all your assertions based on jQuery. Don't do that. It makes your tests fragile. And again, your users don't do things like that. But you can do things like check that values are correct by just going evaluate script. That will return the value that the JavaScript gives you. You can set the wait time of things in Splinter, so you can give your JavaScript time to evaluate or give a really long loading page time to load. It waits for the amount of time specified or the default amount that you say when you create your browser class. So it only works for the element present and element text present, but it's measured in seconds and you can set a default up front. It's a timeout. So what it does is it sits there and it spins over and over again trying to make sure that the actions you're trying to take actually occur. And as soon as it's true, they stop. So you're not waiting until the end of the timeout, you're waiting until the event you want occurs, which has a corollary. If you're ever doing a negative assertion, don't use a high timeout. Because what will happen here is that command will always wait 20 seconds before it hits false. It will return true as soon as it is, and false at the end of the timeout. So the better way of doing this is to flip it around so you're asserting true, browser is element not present by tag. You can manipulate iframes if you're stuck in the 90s. You can do stuff with alerts. So alerts are an interesting caveat. Alerts will take focus away from your browser. So you go browser.getAlert, and then you have to call accept or dismiss. If you don't, it will retain focus and your tests will break. Prompts are much the same, except with prompts you can fill in the value that they want and then go prompt assert, prompt dismiss. The thing is, there's a with form of getAlert, which logically you would imagine with browser.getAlert as alert do a thing. Yeah, no, that's a troll. It won't actually dismiss or accept the alert. You'll still take focus away from your window and your test will break. I don't quite know why that's there, except maybe for feeling good about the fact that you're using a slightly more advanced language feature than assignment. You can specify different browsers, so Chrome or Zope Test Agent, and it's really easy. You do that. You can specify user agent if you want to dick around with what your content's presented as. The default is Splinter. It's really easy. You use Splinter. You can also use extensions and profiles. Profiles are all your user data, like bookmarks and settings. Extensions are different Chrome extensions, like Firebug. One of the caveats about this is if you use a profile and it has an extension in it, for some reason at the end of the test, the extension will be removed from the profile, even if you don't tell it to. So if you use your real profile, it will delete all the extensions from it. So be careful of that. Chrome doesn't have any of those features, but it's just as easy to use. You install Selenium, you install the Chrome driver, and you use Chrome. Phantom.js, install Selenium and use Phantom.js. Zope.testbrowser, install a slightly different version of Splinter and use Zope.testbrowser. Again, this isn't really interesting because it's not really hard to do. And try to make sure you always quit your instances, because if you don't, your tests will hang. And this is one where the with block actually does something. If you go with browser as browser, at the end of your test, it'll close the browser off and continue on its merry way. So there's one more thing about Splinter that's really cool. Splinter can use a feature of Selenium that allows you to connect to a remote server. So you can have a MacBook, like I do, and test on IE, as long as you have a Windows machine sitting somewhere that does IE. The remote server works by having a set of nodes that have a capability, and your client, your tests, ask the Selenium server for an instance of that capability. So I want the B browser, and it will give me that middle connection there and run your tests. Accessing remote servers is really easy. You set up a desired capabilities object, which is what tells the server what capabilities you want. Like, use Internet Explorer, Windows, and version 7, and the URL there is the URL of the server object. Those are the supported remote browsers that Selenium has, so as long as you have something that will run those browsers, you can do it with remote Selenium. And the only remote Selenium server I had that I could get running late at night last night was Source Labs', so I apologize. It's going to take a little while because it was going across the internet. One of the things about remote servers that's really cool is that if you parallelize your tests, don't parallelize your tests, you can run multiple instances of them at once. And say, if you have enough Windows boxes on your network, run across every instance of Windows that you have on your network all at once. So you can go, I want to test Windows 7 through 8 with every version of IE that will run on those. You don't have to have VMs running, and your tests take however much time it takes to execute the longest one of those instead of all of them at once. So I am going to skip to the next video, which is just proof that test actually executed. So I downloaded the video here from Source Labs. Because it ran remotely, it didn't run on that machine there. It opened up an instance. By the way, this is Mountain View. I was running this from my hotel down the road because remote Selenium is awesome. It opened up the Pizza Hut site. It waited a little bit because the IE driver for Selenium is remarkably slow. Da, 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 da. Do Pythonists not like to sing? Yeah, there we go. Okay, we're running out of time, so I'm just going to leave that running in the background. Oh, there we go. So it's going to fill in the postcode form, then it's going to auto-complete the suburb, which there was only 2 options of, and then the video is going to end because recording your screen is a terrible way to run sessions. Excellent. All right. So that's remote Selenium. A couple of general points can be read off the slides because we're kind of out of time and I want to take some questions. So yeah, thanks very much for your time. Oh, one more thing. We decided to give you some free stuff. So if you sign up for Source Labs and use that promo code, you get 1,750 minutes to run your tests remotely or in parallel. Have fun. Questions?
So as Dylan said, we've got a few minutes for questions. I'll bring the mic.
Could you please go back to the iframe slide that you said it can also go into iframes?
Sure.
So I do quite a bit of scraping of ugly SAP sites, and I need to look into the source to check what the random ID for the iframe has been given. And I wanted to check whether Splinter does that search just by text and can go into an iframe by looking into the...
So it takes the name of the iframe and then just switches the focus to it, and you can do all the same operations as you could with standard Splinter on that iframe as though it was a window by itself. And then this form at the end will then switch focus back to the rest of the main frame. No worries.
You're probably going to say this is terrible, but Selenium has the IDE which allows you to quickly generate a test by clicking on things.
Yep.
Is there anything equivalent for Splinter that, you know, would generate that type of stuff?
Not that I know of. It might be possible to create an assistance layer that would be fairly easy by just analyzing your Selenium test and basically abstracting that back to say, you know, navigate _to blah is equivalent to visit. But there's nothing that works by default like a recorder yet. There was one up the front here as well, in the gentleman in blue. I'm going to run this video while I'm answering questions.
Is there anything to take screenshots of the browser or a dump of the image of the browser for a page?
Selenium itself has a screenshot capability. It's not in Splinter yet, but it wouldn't be too hard to add it. Shameless plug, when you run tests on Source Labs, we take screenshots of every action and video of the whole thing. It's a facility of Selenium itself, but again, you'd have to just put that functionality in Splinter.
So do you have any suggestions for actually putting this into your pipeline for developing, how Django has a test suite where you run tests? What's the preferred way to do that with Splinter? I assume it's separate to Django tests and stuff.
I'm kind of new as a Python developer. I started it because they were picking on me at work because I do Ruby. And I guess it works with all the unit test suites, so if I was doing it for Ruby, I would just use the standard RSpec library and I would build specs like that. Maybe I would use Cucumber or Lettuce for Python on top of them. I have ideological differences with the whole idea of Lettuce and Cucumber, but there are some situations where I think it's warranted, like when you have a tightly integrated QA team and a development team, and you don't do that concept of the wall where you throw software over the wall and bugs come back. If you work well together, then Cucumber or Lettuce is a great way of doing that. By the developers create step definitions and the QA people create test suites. There was something I skipped over because I was running out of time, called the page object model, which is a Selenium concept about building models of pages and providing the things that users want to do on them as methods on the page. So on your user page, it might be add friend or attempt to add friend. And then you compose your tests out of calls to those methods. So they read like what a user would do. And those methods themselves return other page objects. So you isolate even Splinter from the actual test code itself. But that's really all there is in terms of recommendations.
You said there was a limitation of not being able to do file uploads with a remote server. Can you work around that with sort of secure shell tunnels?
You could go down to the browser itself from Splinter, I think, and then call the set file remote method, I think, on Splinter allows you to upload a file from one server to a remote server, because otherwise the way it does file uploads is by assuming that the path you pass is relative to where the browser lives. So there is a workaround, but I haven't actually tested it for Splinter. I know it works for Capybara, which Splinter is inspired by, but that's about it. Sorry.
Dylan, as thanks, we have a roast of the Norwegian Blue blend of coffee, and here is a PyCon AU mug for you.
Thanks
Join me in
very much,
thanking.
guys.